It means that when you guys are drawing a circle, all of the points that are on the circle are the same distance from the center. Now, what tool have we used in the past that helps us draw a circle? That compass. Remember that compass thingy that was hard to work with? The pointy part of the compass, when you guys were drawing that pointy part of the compass that you guys would put down and draw around, that's the center. So when you guys draw a circle, which I can never draw a perfect circle, but that little dot that's right in the middle, that's the center. And then all of the points that are around the circle, those are all the same distance away from the center. That's what defines it as a circle. If it was all wobbly, I know when you guys were using the compass, it was wobbly, right? So sometimes your circle would not look perfect. But a perfect circle, all of these points that go around should all be the same distance. Your compass would not move. Okay? So that's the definition. Concentric, and then centric circles are circles that have the same, or I'm going to actually, just to use for words, that share a center. Concentric, the centric part meaning center. So concentric circles, they share a center. So think about a bullseye. Do you guys know what a bullseye is? Like the little target thingy where you have a bunch of circles, one smaller than bigger. Those are all concentric circles because they have the same center. They all have the same center, you just have different sized circles going around it. That's what concentric means. Alright, now let's get into words I'm sure you guys know. A segment that goes through the, when you draw a diameter, what does it have to go through? Can you just draw a random line? What does it have to go through? Which is called the center. So you have to go through the center and has endpoints on the circle. You guys have been drawing and identifying diameters, but you probably never defined it before. So that's the definition of a diameter. It is a segment, which means it has a start and a stop, that goes through the center, and its start and its stop points are on the circle when you guys draw it. So if you want to draw a little picture here, you can, like that. You just choose a diameter. It goes through the center, and then it starts and stops on opposite sides of the circle. I'm sure you guys have heard of a radius as well. A radius is a segment that has one endpoint where? At the center, and the other endpoint would be on the circle. I'm sure you guys have seen this before. Like that. What's the relationship between a radius and a diameter? Radius is half the diameter. So the diameter goes both ways across the entire circle. Radius only goes halfway from the center out. Alright, some new words you guys may never have heard of. We have something called a central angle. A central angle is an angle whose vertex is at the center. The vertex of this angle, it's going to be inside of the circle, and it's called a central angle because the vertex is at the center. So if I draw I'm going to draw a little picture right here. If I draw a circle, and I have the center right here, if you draw that, it's like a piece of a pie, essentially, if you guys, or a pizza or something. If you cut out a slice of pizza, this little angle right there at the center, that's called a central angle because it comes from the center. Right? What would I call the sides of the angle? What do I call those two?
Those are radii.
Yep. Do you guys know what the plural of radius is?
Radio.
Mm-hmm.
Radius is.
Nope.
Radii.
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 2 eyes. Radii. Alright, so this is probably the most important word on this page, knowing what a central angle is, because we're going to be talking about other types of angles, like inscribed angles and other things. So you guys need to be able to know what a central angle looks like. So it comes out from the center is where the pointy part of the angle is. Alright, an arc. An arc is a part of a circle. Part of a circle, or a fraction of a circle. So an arc is basically an incomplete circle, is basically what it is. So you guys remember when you had your compass, you didn't always draw a full circle, you guys just drew like a swoop, like that. That's an arc. So when you guys are just drawing a part of a circle, not a full circle, but just part of it, it doesn't matter how big it is, you just draw a part of a circle with that little kind of swoopy picture, or using a compass, that would be an arc. Now we have 3 types of arcs that we're concerned with. We have a minor arc. which is an arc that is less than half a circle. So if you guys are only drawing a little tiny arc, it has to be less than half a circle in length. So if you're only drawing less than half a circle, that's called a minor arc. If you guys are going to draw a major arc, that has to be more than half a circle. So you have to draw half a circle and then go a little bit more. To get more than half a circle, it's called major. Hopefully you guys can see the connection between minor and major. And then what's a semicircle? It's exactly half a circle. So we have less than, more than, and exactly half a circle, and they each have their own special name. Minor, major, and semicircle. Now, it's important that I've put in these parentheses here is the way that they name things. So you guys remember how to name an angle? How many letters do you use to name an angle? 3. You have the end, you have one edge, then you go to the vertex, and then out again. We use 3 letters. How many letters do you use to name a segment? 2. You have one endpoint and the other endpoint, right? Now, this is very important. You guys know how to name arcs. When it's a minor arc, you guys are just going to use the endpoints. So how many endpoints would there be for a minor, or for an arc? How many endpoints would there be? It would be 2, a start and a stop. So there are going to be 2 endpoints. So how many letters would you use to name a minor arc? 2 letters. So to name a minor arc, you're going to say, I start here, I stop here, that is arc AB or something, whatever the 2 letters are. Okay, and we'll see this in a second. If you guys are going to be naming a major arc, however, you guys must use 3 letters. In order to name a major arc, you guys are going to be using the endpoints. So if you start at A and you end at B, that's still good. But you also have to have one letter that's in between. So let's say if you had an arc like this. A, B, C. If I wanted to name this arc right here all the way from A all the way around to C, I can't just say AC. Why can't I just say AC?
Especially from there to AC.
Yeah, AC would be here. If I just say AC, you guys don't know which way to go, do you? If I say arc AC, you have no idea whether I mean this or that. So when you guys are naming major arcs, you guys need to also include a point in between. So if I wanted this full major arc right here, I'd have to call it ABC. So it's kind of like an angle. So that's very important that you guys know the difference between naming a minor arc and a major arc, because if you mess up and you accidentally name the major arc AC, you're actually using the minor. So you guys have to be really careful with that. And then you guys can name a semicircle however you want. You can either use 2 or 3. You'll see them back and forth. More often they just use the endpoints, but you guys can use 2 or 3, it doesn't matter. You can't make a mistake on that one. The minor and the major you have to pay attention to. Alright, there's our vocabularies. Anybody have any questions about that? Because now we're just going to move on to talk about 3 formulas. So you guys should know at least 2 of them. Any questions about the vocab? I haven't seen one so long. Alright, a couple more vocab words that we're going to associate with some formulas. So take a look at arc measure. Oops. Alright, so arc measure equals, I'm just going to go right into it. Arc measure equals the central angle, central angle that creates it. Might go off the line a little bit. Okay, so if I ask you for arc measure, I'm asking you essentially to find the angle measure, right? Because an arc is bent, right? We can't really find we'll talk about its length in a little bit. But when I ask you for its measure, because it's bent, you guys have to use the angle to help you. So all you guys need to remember is that if they ask you for the arc, you use the angle, right? What do you guys think half a circle would be a semicircle? How much do you think that's worth? What would the measure be? 180, because how much is a full circle? 360. So that is something you guys need to remember. Hopefully you guys know that already. Full circle is 360. The measure of a semicircle or half a circle is 180. Okay, now we're just going to go through this exercise, see how I've named the arcs here. The little symbol that is above them is just a bent line. Mean arc. So I'm looking for the measure of arc BC. Is this a major arc or a minor arc?
Major.
Yeah, there's 2 letters. Is this minor or major?
Minor.
Minor, because there's only 2 letters. Does that mean it's going to be greater than 180 or less than?
Less than.
Less than. Okay. So let's go find BC. Let's look at our circle and find BC. So I'm going to start at B and then end at C. So I'm looking for this red arc right here. When they ask you for the measure, which is represented by this M, the measure of this bent segment is equal to the central angle. So what's the central angle that creates that arc?
32 degrees.
32. So that means that the measure of arc BC is 32 degrees. I know it's weird to think of a little bent segment being in degrees, but that's what they mean by measure. Okay? Now we're looking for BD. Is that minor or major? Minor. So I'm starting at B and I'm going all the way to D. So I have this entire segment of the circle right here. So how would I do that? You'd add them together, right? It's just like the segment addition postulate. We have the arc addition postulate. So if I have this segment and this segment together to create BD, that arc, I would add them together. So it's 32 plus 58. Yes? Degrees. I'm being very intentional about writing degrees so you guys know what unit we're using here. This is a measurement, not a length. All right. CAB, is that major or minor? That's major. When you guys see three letters, that's major. So I'm going to start at C. Now, what direction do I go in? Towards A, and you keep going and you stop at B. So I want all of that. Start at C, go past A, and then end at B. That's why they give you those three letters to help you. So how would I find that?
16 minus 32.
You guys can use subtraction to help you. I want the full circle except for this slice of the pie. Okay, so what's a full circle again? It's 360, and how much do I not want? 32. We found that previously. So all I have to do is 360 minus 32, which is 328. There you go. Your angle measures here can be greater than 180 because we're talking about arcs here. I know it's weird with the degrees, I understand. But they can be more than 180. They have to be if it's a major arc here. All right, what about AD? Is that minor or major? Or something different? It's minor, so A to D goes right here. How would I find that? Okay, where did the 180 come from? Yeah. So what do I call, I'm going to use a different color. What do I call CA, this whole segment?
No, that would be a diameter.
This is a diameter which cuts the circle into two semicircles. So you're going to use that vocabulary word just in a slightly different way. So the full semicircle is all the way around like this. Well, just like Daniel was saying, I know that all of this is 180. I don't want the 58. So how do I find this? 180 minus the 58, which is 122. Right? 122. So you guys can use the full circle being 360. You can use semicircles and subtraction. There's all sorts of different ways you guys can use numbers that you already have established, the 360 and the 180 to help you. But you could also add sections together if you need to, like we did for BD. Alright, so just remember that the arc measure is equal to the angle, and you use that information to move forward. Make sense? Alright, try the next one by yourself. All four of those based on this picture. See if you can figure out those four. Write them down, and then we'll check your answers. Alright, does anybody know what the measure of arc PR is?
77.
77, very good. 77 degrees. What about the measure of arc PS? 180. What do I call that? A semicircle all the way from P to S. Those are two endpoints of a diameter. Always look for diameters. They could be your way out if you're looking for what a number actually should be there. What about The measure of arc, RS, should be 103. And then what did this one switch a little bit? Now they want the measure of an angle. So it goes back and forth. If you guys know the angle, you can find the arc, or if you know the arc, you can find the angle. It goes, they have that back and forth relationship like a biconditional. So what would the measure of angle QCS be? This central angle right here. 28. Because that's what the arc is. Alright, the arc is equal to the angle is equal to the arc. It works both ways. So everybody able to do that? Yeah, everybody okay with arc measure? Okay. Any questions? Alright, circumference and area, I'm sure you guys know. These two you do not need to memorize. They will be provided for you on the formula sheet. The circumference and the area formulas. Just to remind you what they are though. What is the circumference? What is it? This is a special word for a circle that other shapes just have a generic word that we use. Perimeter. The circumference is the perimeter of a circle, but we can't use perimeter because perimeter implies that they're sides that you add together. So for circumference, it's the distance around a circle. Which again is just basically talking about perimeter. It's the full distance around the shape, which is a circle in this case. There are two ways you guys can see the formula. I don't remember which one they have on the formula sheet. They may have both. But you guys can think of circumference as 2 pi r, so 2 times pi times the radius. Or because 2 times r is the diameter, you could also think of it as pi times the diameter. Okay, we're going to be using the pi symbol. You guys may in the past have used 3.14 and just plugged it in that way. No more. You guys are actually using the pi symbol in your work and in the calculator and then rounding later. So just keep that in mind. That's what we're going to be using in this unit. So that's circumference. What about the area? Hopefully you guys know that's the space taken up, right? Space taken up by a circle. That's what area is in general. It's the space taken up by a shape. And again, the formula for that is pi r squared, or pi times the radius squared. And again, those you've probably worked with before, they will be on the formula sheet. So you don't have to work too hard to memorize those. Henry, come on, put it in your back. I know you can't. You don't have the self-discipline. Put it in your back. Alright, so memorize those if you don't already, or just you can depend on the formula sheet, whatever, that's fine. But do keep those in mind because we're about to use them right now. So the next formula we're going to talk about is arc length. This one you will have to memorize. It is a little bit weird looking. It's odd, I understand. So it's a little bit tricky to memorize, so you guys really need to work at it. Arc length, the definition of that, next page, the distance between endpoints of an arc. I didn't make the line long enough for that one either, sorry. The distance between endpoints of an arc. This is basically like part of the circumference, because an arc is part of a circle and I'm trying to find the distance or the length of an arc. It's part of the circumference. So notice this right here. What is 2 pi r? We just talked about it. What does the 2 pi r represent? Circumference. Go ahead and write that down. Circumference. Right. So because this is a part of the circumference, we have to figure out how much of the circumference is it. Is it a fourth of the circumference? Is it an eighth? Is it half? Is it 3/4? No. So in order to figure out what the part of the circumference it is, we use this fraction. When you're trying to find parts of things, it's fractions. So to find how much of the circumference you're using, we use this fraction, which is the arc measure divided by 360. So it's how much of the circle do I have divided by what the full circle is, 360. So let's say that my arc measure was 90. If I have 90 over 360, that would, if simplified, be a fourth. So if I know that the arc measure right here is 90, that's fourth of the circumference, a fourth of a circle. So the way that you figure out how much of the circumference to use, we use this fraction. So you guys want to memorize how this works. We're going to use this fraction times the circumference, 2 pi r, and that's how I find arc length. Okay? What you need to know is what the arc measure is. You need to know arc measure and radius, and those are the only two things you need. Once you know what the arc measure and radius are, you just plug them in. A lot of ways to do problem solving is to write down what do I need to know, what am I finding, and what do I know. And so that's why I've included this here, so you guys can think through that process. Alright, so let's look at this little circle right here. I don't know if that's blue or showed up on your notes, but I'm looking for this arc right here, AB. So, for this formula, what do I need to know? Arc measure and the radius. What is the arc measure? 60, because the angle is 60, that means the arc measure is 60. They may give you the angle instead of the arc measure, but because we know that they're equal, find it. So the arc measure is 60. What's the radius? 7. So now we're just going to plug it in the formula. Just plug it in. So if the arc measure is 60, I'm going to do 60 divided by 360. I'm going to put that in parentheses just to keep it safe, so I don't mess it up. And I'm going to do 2 times pi times what?
7.
7. Alright. I'm going to neaten this up a little bit just so it's easier to put in the calculator when we use it in a second. If I simplify 60 over 360 as a fraction, what does that simplify to?
6 over 36.
More. 1/6. You guys can use your calculator to do that if you need to, but what you want to do is simplify the fraction if you can. So this is 1/6. So this is 1/6 of the circle. There are 6 of those that make the whole circle, so it's 1/6. And then I'm going to do the 2. I know this is written in this order, but you guys can multiply the 2 and the 7 together. So it's 2 times 7.
14.
So you guys can multiply those two numbers together, even though they're on opposite sides of the pi, you can combine them. So you can multiply those two, you get that. So now what you want to do is just plug this in your calculator. Exactly how I've written it, with the parentheses and everything. Okay? So you want to write parentheses, 1/6, close parentheses. You have the fraction safe. You don't muddle any of the numbers. So 1/6, and then 14, and then the pi symbol. I don't remember exactly where that is. The pi symbol on your fancy calculators
Second over
is second, and then this symbol.
Yeah.
That's called a caret. So if you hit second and then the button underneath clear, the pi symbol should show up. If you have a different type of calculator, can't help you, don't know where it is. Alright, but you type 1/6 and then 14 and then the pi symbol and then push enter, and then what do you guys get? 7.33. Awesome. 7.33. Does it repeat or is it just 7.33? Okay, so we'll just say that then. 7.3 inches, because the radius was in inches. Alright, and that would be the arc length. Alright, so it's just as simple as know what the formula is, know how to find the arc measure, which we previously talked about, know what the radius is, and then plug them in. That's how we find arc length. Okay? Now there are 2 ways to show your answer, and I'm going to show the second way on both of these too. They may or may not want the answer as decimal. And so I'll show you how to write it as a non-decimal in a second. But this is okay for now. So let's try this. Sort of. The other way is to actually not use the pi symbol in the calculator and just leave it handwritten. Which I'll show you in a second. Alright, so for this one I'm trying to find the length of AC, which is a minor arc here. So what 2 things do I need to know? I need to know the arc measure. And I need to know the radius. So what is the arc measure? No. 220 is referring to this angle right here. How did you find that? So the 220 is referring to the angle that is not with the arc I want. This angle is referring to ABC. So if I want to find this angle, I'm going to have to do 360 minus the 220, leaving me with 140. They will do that sometimes. Right? They're like, it's too easy to just have the numbers and plug them in. We'll switch it up on you. So make sure you guys have the correct angle, and if you don't have the angle that's actually working with the arc you need, just use 360 minus that other one to find that angle. Did everybody see what I did there to find the 140 and why I needed that instead of the 220? Everybody get that? Okay. So now I have the arc measure. So it'd be 140 over 360 for the first part of the formula. Then I'm going to do 2 times pi times what? 10. That's my radius. All right, let's simplify. So if you guys can really quickly put 140 divided by 360 in your calculator, what does that simplify to? As a fraction. 7 over 18. Okay. So working with the smaller numbers just makes it a little bit easier. You don't have to, but it does make it easier. So I have 7 over 18 to simplify. So this is 7/18 of the circle. Then you guys can multiply the 2 and the 10, which is 20. And then the pi, right? So now I'm going to show you both ways to write the answer. So for the first one, just type exactly what you see in the calculator. Parentheses. 7 divided by 18, close parentheses, and the 20, then the pi symbol, and the percenter. What do you guys get? 24.43 feet. I am going to start to become a stickler about units. Make sure you're practicing with that. Alright, so that's one way to write your answer. So if the directions say please write your answer as a decimal or something like that, that's how you'd want the answer. However, if they say leave your answer in terms of pi, if you see in the directions it says leave your answer in terms of pi, that means they want you to put everything in the calculator except for the pi symbol. Except for the pi symbol. So now for this version of the answer, I want you guys to just do 7 divided by 18 times 20. Just do that. What do you get? Okay. So sometimes you'll have a decimal incorporated in it, but if they ask you to leave the answer in terms of pi, this is how you would write it. You would only find the non-pi numbers multiplied together and then handwrite the pi symbol, and that's it. Those are the exact same number. One's just written in terms of pi, which means you actually physically write the pi symbol instead of multiplying it into the number. And so either of those two numbers you guys need to get used to using. And that's where you guys have to read the directions to know which one they want. So if they say leave your answer in terms of pi, in terms of pi, that's what they want. And if you do not write it like this, you will be incorrect. So you need to make sure you're writing it correctly. All right, go ahead and try the last one on your own, please. I've done 2 models here. So go ahead and find the information you need in that last one, plug it into the formula, and please write your answer in both formats, both as just straightforward decimal and in terms of pi. Please write both.
It does.
Remember, on the first day of school, the power went out.
Switch off batteries. Alright, write your answer in both formats, please. Full decimal and in terms of pi. Alright, so anybody have an answer for me? I only have the in terms of pi one written down. So hopefully you would have done 50 divided by 360 times 2 pi times 5, which is 5 over 36. And again, that simplification is not essential. You guys could technically do 50 over 360 in your calculator just like this, but it does make it a little bit easier to work with smaller numbers. So you type that in the calculator, what do you guys get? 4.36 centimeters. That's the one format. Now what would it be in terms of pi? 1.38. 1.38 pi. Remember, both of those are the exact same number. One is just written without the pi multiplied into the number. It's written as a symbol. The same way you guys would write 3x. And then instead of finding what x actually is, just leaving it as 3x. So make sure you guys are used to writing both. Now, before we move on from this, the biggest thing that I've noticed in the past is students confusing arc measure with arc length. See how similar they sound, measure and length? They might mean the same thing for segments, like straight lines. We were talking in the past, like find the measure of segment AB could be the same thing as finding its length. In a circle, that is not true. So it's very important you guys are able to tell the difference between arc measure, which is a degree, like the angle relationship, the degree measure, and then arc length, which is an actual centimeter, inches, distance length. Okay? Very important you guys keep those separate from each other. Yes?
I'm still confused on like how to put it in pi. Keep it as pi.
The pi symbol, with like writing it like this or writing it like this? The first one?
Pi symbol.
Okay, all you do for the in terms of pi is literally don't put that in the calculator. Put everything else. Do 5 over 36 times 10. Find that number and then handwrite the pi. Okay? Everybody clear on that? Everybody good? Everybody check, check, check on the first page? Yes.
Can you give us a fraction?
Which one?
The second one.
Yes. Yep. As long as it's simplified. Okay? Alright. Everybody's good with that? We're going to go on to our last formula for today, which is sector area. Sector area. So you guys already taught, we know about area of a circle, right? Oh yes. Go ahead. So the area of a circle is pi r squared, right? We just talked about, we didn't do any examples because I'm sure you guys have seen that before. The area of a full circle is pi r squared. A sector area is finding the area of part of a circle. The area of part of a circle. And that part of a circle filled in is called a sector. Part of a circle around the edge, just the edge part, is an arc. When you shade it in, a slice, maybe a better word is slice. Slice of a circle, finding the area of a slice of a circle, that's the official name for that slice is a sector. And so that's why we have these shaded in bits, the gray part here. We're looking for the area of those pieces of the circle. And so this formula is very similar to what we were just looking at. Present. Nope. Which is, this is area. This is area. And then we're using the exact same formula part that we did before. We're trying to figure out how much of the circle do we have. How much? Is this 1/4 of a circle? Is this half of a circle? Is it 2/9 of a circle? How much? In order to do that, the exact same way as we did before, arc measure divided by 360. So it's the exact same formula, we just switch between circumference and area, depending on what we're looking for. So if you're looking for the arc, which is just this outline of a circle, that's going to be the fraction times circumference. If you're looking for the shaded in part, this is fraction times the area formula. Okay, so they do have connections and things you guys already know, the circumference and area formulas, you just have this extra fraction part. So what are the two things I need for this formula? Okay, I need to know arc measured, and what else?
Radius.
And the what? Well, what do you need in order to find the area? The radius. So you need the exact same information as last time. You need to know the arc measure and the radius. Once you know what they are, you plug them in. So it's the exact same process as before, just a different formula because we're looking for a different aspect of the circle. Okay. So for this one, I need to know how much of the circle I have. So in order to do that, I'm going to do the arc measure divided by 360. What is the arc measure for this grayed out part right here? 125. Because remember, the arc measure is the same as the angle measure. So angle measure, arc measure is 125. So I have 125 divided by 360. And then instead of doing 2 pi r, like we did for the previous one, I'm going to do pi r squared. Because I'm looking for area this time, not length. This is area. And now I simplify just like we did before. I don't think 125 over 360 simplifies.
No. I remember.
Oh yeah, it does.
5
Again, this is something I like to do. You don't have to if you just want to plug in 125 over 360, that's fine. I like to simplify the fraction, so either do that or not. It's up to you. And then pi, and then what's 8 squared? 64. So now what you guys want to do, and I know the pi is in a different position, but don't let that bother you. You just type it in exactly as you see it, and we're going to write them in both formats, the just straight up decimal, and then also in terms of pi. So if you type that into the calculator, exactly as you see it, what's the decimal? It should be, look carefully at what you typed in. It should be 69.81. Alright, that's the decimal one. Now I also want the answer in terms of pi. In order to, again, to write things in terms of pi, you're going to type everything except for the pi symbol in the calculator. So you do the fraction, whichever one you use, the simplified or unsimplified, times 64. What is that? So that's your answer in both formats. The straight up decimal one, and then your in terms of pi, which is just these two numbers with the pi symbol handwritten, not multiplied. Okay? Questions in that first example? Alright, I'll start the next one with you, have you guys finish it, and then you'll do the last one on your own. So for this one, I want the area of the shaded in, this grayed out part. Okay, what's the arc measure for that?
300.
How did you get to 300? Because I see a 60 right there.
You subtract the 360 from the 60.
Other way around. Oh, you're right. So the 60 is talking about this angle right here, which is the white section. I don't want the area of the white, I want the area of the gray. So to find the grayed out section, I'm going to have to subtract that away from the full circle, which is 360. So if you subtract 360, you get 300, just like Henry was saying. So the angle I'm actually focusing on is this angle right here, which is 300. And so what would my formula look like? Well, before you simplify. Okay. Pi times 9, because 3 squared is 9, right? And then you can simplify the fraction or not, it's really up to you. But if you simplify the 300 over 360 to make it easier to work with, that's 5 over 6. Alright, and I'll let you guys go ahead and find both forms of the answer, and then do the third example, and I'll make sure that both of them are right in a second. So find your final answer for that, and then move on to the third one. I accidentally left off on the units over here. When you guys are finding area, it needs to be inches squared. Alright, let's distinguish the fact that it's a two-dimensional area instead of just the length, which is one-dimensional. So don't forget that like I did. So if you guys wrapped up this question correctly, you guys should have gotten 23.56 centimeters squared. And then in terms of pi, I believe it was 7.5 something. Okay, exactly. That's cool. Okay, so that's how you should have wrapped up that second one. And then the third question, you guys should have gotten 9.77
Yeah.
feet squared, or 3.1 repeating pi. Those are the answers you should have gotten from that third one. Any questions on that? Okay, so you do have to memorize those formulas. The arc length, which is the circumference one, and then the sector area, which is the area one, with the extra fraction at the front. So make sure you guys remember those. Okay, now what we're going to do, remember we were in the polygons unit, we learned the formulas for finding angles. Found the 180 n minus 2, all that. Not only did we learn how to use the formula forwards by plugging in n and finding the answer, right? We also solved backwards, where they gave you the angle measure and they wanted you to solve for n. Remember how we did forwards and backwards? We're going to do the same thing with these. Anytime you guys learn a formula, you have to know how to work forwards and backwards. So for these ones, they're going to give you information. You're going to figure out what formula you use, and then you're going to solve backwards for whatever they're asking for. And that's what we're going to do here. So pay very close attention to what we know and what we're going to use to find what we don't know. So we're going to work backwards. So this one says, find the circumference. That's what we're looking for. All right, circumference is the same thing as 2 pi r. I'm just going to write that down and save it for later. Okay. Now what we need to do is figure out, what do I know? What do I have? What did they give me? What have they given me in this question? I'm going to draw little arrows, and you guys are going to tell me what it is. I'm going to label them. So what is the 130? Okay, that's technically the angle, but it does give me the arc measure. So I could also put it right here at 130 degrees. So I have the arc measure. Cool, I have that. What is the 15 inches? Arc length. Good. So I have both the arc length and the arc measure, and I need to find circumference. So what formula would I use to solve backwards? What formula has both arc length and arc measure? So I can solve backwards. Well, what formula has the arc measure, the arc length, and the circumference all wrapped together? They're all working together. The arc length formula. Right, remember arc length? So arc length is equal to the measure divided by 360 times 2 pi r. This is an abbreviated way of writing it, but that's what the formula is for arc length. Do I know what the arc length is? 15. Do I know what arc measure is? 130. Do I know what the circumference is? No, that's what we're looking for. So what I'm going to do, instead of writing 2 pi r, I'm going to write that as x. Because I'm looking for I'm looking for what 2 pi r is as a whole. So I'm just going to write an x right there, because that's what I'm looking for. Looking for circumference. Alright, so how would I solve this? Use your algebra.
Can we simplify it first?
Sure, you can simplify that. What would 130 divided by 360?
13 over 36.
Okay, so you can simplify. You don't have to, but if you want to make the number smaller, feel free. So now I have this.
And then you just multiply 36 to 15.
Okay, multiply the 36 over to get rid of the fraction. So it's 15 times 36.
540.
Okay, so now I have this. How do I get x by itself?
25 by 13.
Very good. So x is equal to, yes, well, rounded 5/4. There you go. So that's the thought process, the problem solving you need to go through. You need to know, what do I have, what am I looking for, what formula has all that? What formula can I use that I can plug into that has all that stuff working together, and then solve backwards? Okay, let's try the next one. I'm looking for the central angle. Where is that in this picture? Where would you find a central angle? In the middle. I'm going to call it x because they haven't really named it anything else, so I'm just going to call it x right there. That is a very good question. Would the answer just be 6.98?
No.
Why not?
It doesn't have a degree symbol.
It does not have a degree symbol. What is this right here?
Oh, that's the measure.
Arc length. That's why it's so important you guys know the difference. Arc length is not the same thing as arc measure. So Henry picked up very well on the fact that this does not have a degree symbol. Remember, arc measure has degrees? Remember that? This is 6.98 meters. That's arc length. You guys have to really pay attention. Use your eyes. Look for that important information. That's arc length, not arc measure. So I can't just say x is equal to 6.98 because that's not the relationship. All right. What's the 4?
Radius.
Okay. So I need the formula that involves arc length, the radius, and the central angle. What formula uses all those things? Has the arc length, the radius, and an arc measure. The arc length formula. The arc length formula works with radius and arc measure together to find arc length. So that's the formula I'm going to use. Your options are just those two that we learned, the sector area and the arc length, so not a whole lot of things to sort through. Alright, do I know the arc length? Yes, so that goes here. Do I know the arc measure? No, I do not. That's what I'm looking for. So you can either leave it as M or you can write it as X, since that's what we have in the picture. Do I know what the radius is? Yes.
Yes.
It is 4. Okay, so let's neaten this up a little bit. What can I do?
You can do 2 times 5 times 4.
What do you mean? You have to find that number, you mean?
Yeah.
Okay. So what would it be? 8? Or no, that whole number with the pi also built in. Like 8 times pi.
Then be like 25.13.
Okay. So you can do that just to shrink it down a little bit. Not divide by 360. Multiply by 360, so 6 point, I don't know what that is. Okay. Alright. Now,
And then she divided by 25.13.
what do you get?
Like 99.99 or so.
Yep, it's pretty much 100. Alright, so that would be your answer for the angle, the arc measure, the angle right there. The central angle is 99.99, just about 100. Right? And solving backwards can do more work, but it's just algebra, and you guys have been through algebra already, so I expect you to be able to do that. Alright, so what I'm going to have you guys do is see if you can do the last two on your own. Again, figure out what do I know, what am I looking for, which formula will help me get there, plug it in, solve backwards. Alright, so go ahead and practice a little bit with those, and then we'll Alright, so for this first one, does anybody want to share what answer they got? For the radius? Okay. 0.52? No, that's not quite right. Yes? No? Anybody else have a different result? Huh? Nope, that's not right either. Anybody else?
60.
Anybody else get a different number? Yes?
60.
Should be, yeah, 66.2. Should be 66.2. Okay. So for this one, huh? For this one, you have the 90-degree angle here. Just because it's not a number, you can't ignore it. So this is a 90-degree angle, which means that the arc measure is also 90 degrees. I know the arc length. I'm looking for radius. What formula would I use? The arc length one. Again, you only have two options. It's either the sector area or the arc length. So they gave you the arc length. So you're going to use that formula. 2 pi r. They gave you the length was 104. I know the arc measure is 90. What I don't know is the radius. Okay? So for this one, you guys would multiply the 360 over and then divide by 90. That's probably the easiest way to do it. There are a lot of different ways you can finesse the algebra for this one. Calculator right here. But for this one, sorry, I don't know all of the intermediary numbers. You would multiply the 360 over and then divide by 90. So we can do this. Oops. 416 equals 2 pi r. And then you guys can find what 2 pi is. So 2 times pi is approximately 6.28. And since I'm just trying to find radius by itself, you would divide that number away. You could also just divide by 2 and then divide by pi, 2 separate divisions. But if you find what 2 pi is and then divide it away, you can do it in one fell swoop, which gives you that 66.2. So I don't know what happened with the algebra for those of you who didn't get that number, but hopefully you guys are able to see that now. Of course, there are different routes you can take with the algebra, but they should all end here.
I did 104 times 36 divided by 9.
Oh, you took the zeros away?
Oh, I guess I stopped that at 416.
Yeah, you'd have to keep going because they want the radius. Then you have to divide the 2 pi.
I stopped right there.
Okay? And then for this, yes, question? For this one, you guys should have gotten what? What did you guys get for the last one? Anybody wants to share their answer? Yes, Cal?
7.05.
Yes, 7.05. You get 7.05 for that one. This one gave me the sector area and the arc measure, and I'm trying to find the radius. So what formula would I use that involves the radius, the sector area, and the arc measure? This is the sector area one. So remember, the sector area is the same formula with the fraction, but now you're using pi r squared because we're talking about area this time. So again, you take stock of what you know and plug it in. So I know that the area is 20 pi. I know that the arc measure is 145. And I'm looking for r, or the radius in this scenario. Now there are a couple different ways you can do the algebra for this one too. Because there's a pi on both sides, if there's something the same on both sides, can't you guys divide it away? So if you wanted to, you guys could just erase the pi's. Basically cancel them out. Cancel out the 2 pi's if one's on each side of the equal sign. Otherwise, you can just find out what 20 pi is as a decimal. You can do that. That gets rid of the pi as well, kind of melds it in with the number. But because you had a pi on both sides, you can cancel those out. Instead of erasing, I'll just slash. Okay, you can ignore those. And then like we did over here, multiply the 360, divide the 145, and then take the square root. Because when you guys have a square, you need to take the square root to find the answer. And so doing the algebra, again, you guys should be able to do that because you've been through algebra 1 already. You should end up with 7.05. Okay, so for these questions, you really do have to think. It is a problem-solving process. You need to think, what do I know? What formula has all that information? What am I looking for? How do I solve backwards? Do the algebra, and you'll get there. Okay. So I understand the forward direction is a lot easier. Just plug in and go, but